Welcome to the project demonstration of solar based wireless battery level management system along with wireless power transmission. So here the main application and the features of this project is we are going to transfer the power from source to the receiving section, and that will be done through the wireless power transmission concept. And the next, in the receiver section, we are using the battery level management system with the help of PIC microcontroller, which is continuously measuring the battery voltage, and whenever the battery voltage is lower than the threshold value, then the system will on this electromagnetic relay to allow the power supply from the receiving coil. So here we place the receiving coil, and the receiving power will be given to the battery pack whenever the battery level is low, and the receiving voltage along with the battery level voltage continuously displayed on the 16:2 LCD screen. For that purpose, we are making use of two voltage sensors. One is for the receiving coil and there is for the battery level, and that will be displayed on the 16:2 LCD screen. And coming to the interfacing connections at the receiving section, these two voltage sensors interface at the pin number A0, A1 and C7 to the relay, which is used to allow the power from the receiving coil to the battery pack whenever the battery voltage is less than the threshold value. And the output status displayed on the 16:2 LCD screen continuously. We have interface at the pin number B2 to B7, and this motherboard consists of PIC 16F72 microcontroller, and on the board we can see the regulator which will take 8 volts DC. So the battery ratings in the receiving section is a 8 volts 1 amp battery, and there we can see the two batteries are in series. So each battery of 4 volt 1 amp, these two are in series, so it gets 8 volt 1 amp output. That is the input to the motherboard, and we need 5 volts DC output. So that's why we have placed the 7805 voltage regulator which will take 8 volts 1 amp DC input and provide us a 5 volts DC output. So this is all about the receiving section along with the interfacing connections. Coming to the transmitter section, so when we want to transmit the power through wireless, there we need to use the mutual induction concept. There's a mutual induction EMF, the electromutual induction force will be generated around this copper coil, and to generate that we need to provide the high frequency AC signal to that. To provide the high frequency AC signal, we need to convert the DC to AC. Why? Because we are getting generally from our grid, we'll get 230 volts of AC with 50 hertz of frequency. That won't provide the maximum EMF around this copper coil. So that's why we need to convert the AC to DC, and we need to store that in a battery pack. So when we are talking about the battery pack, then it can be rechargeable either from the grid or from the solar panel, so which is a renewable source. So just we are placing the solar panel as a renewable source, and from there, and grid also is parallelly connected to the battery pack for charging purpose. Coming to the battery pack, we are using 12 volt to 1 amp battery pack. So as we have discussed, 3 or 4 volt 1 amp batteries are connected in series. So we'll get 12 volt 1 amp DC outputs. The DC output is input to this MOSFET. So the MOSFET which will acting as a switch to get the pulse signal from this nano board, so which is used to provide 120 kilohertz of frequency signals to this MOSFET board, so which is acting as a switch between the 12 volts DC input and the copper coil. So faster manner we are switching the DC to the AC, we are converting with the help of MOSFET and the nano board, and that 125 kilohertz of 12 volts AC signal is input to the copper coil, so that we can generate the EMF signal around this copper coil. So whenever we place the secondary coil, so here this is acting as a transmitter coil. When we place the receiving coil which is acting as a secondary coil, then the induced EMF will be generated inside this coil, and that will be the same 125 kilohertz of frequency AC signal that will be converted into the DC with the help of DB107 IC and filtration. After that, the DC around will get maximum of 12 volts of DC that will be input to the battery pack through this relay. So let us see the demonstration. So before demonstration, keep the battery under charging. It will take around 4 to 5 hours to be fully charged. Till the duration, keep the battery under charging, and now place the solar panel under the sunlight. So if we get either from that, because if you can't only transformer, so as we discussed 4 to 5 hours, or from the solar panel only 4 to 5 hours. If you place both at a time, means maximum power getting from the solar panel, and we connected the transformer also, then the charging time is only 1.5 hours as we getting the maximum power to the battery for charging purpose. So this is the main on off switch. So when we on this, the status on the Arduino will show it is transmitting the power, means it's provided the EMF signal around this coil. So just on this receiving coil. So as of now, the R voltage nothing but the receiving voltage is 0 volts, and B voltage nothing but the battery voltage is 7.7. So when we place the secondary coil, So as we can see on the LCD, the voltage is increased. Slowly the power is transmitting from the transmitter coil to the receiving coil. The receiving voltage is 9-10 volts, like that. So if you increase the distance also, then the voltage will be transmitting, which is sufficient to charge a battery pack. So around we place around of 6 to 7 centimeters of distance, the power is transmitting wirelessly. So if you place very near to that, then the power is maximum we can receive 13.5, 15 volts we can receive that. Okay, so here whenever the battery voltage is low, for that purpose just we are making a disconnection of battery from the voltage sensor, so that just to inform to the microcontroller about the low battery voltage. So you can see the 0 volts here. So the capacitor which was there at the receiving coil is slowly discharging. So when connecting over there, right. Right, okay. Right, as of now the battery is getting charged, so we can see the voltage, and the battery voltage was as I've disconnected that. So when we connected back, so whenever the battery voltage is above 8.5 volts, then the relay will be off, and when it is below 6.5 volts, the relay gets switched on. So whether it's a 0, 1, 2, 3 volts, relay is on state if the battery voltage is less than 6.5 volts. As you can see, the receiving voltage, our voltage is around 11 volts. So when we remove from there, you can see the voltage is decreasing. Slowly the capacitor is charging, the voltage also showing low voltage, and when we place it on this copper coil again, then the induced EMF will be generated and we get the maximum voltage. So here we are controlling the battery level over here along with battery level management with the charge controlling and wireless power transmission from the solar panel. Thank you.